So just a quick overview of the Quantum Strategy Institute. So for like many people here who have been attending conferences for the last number of years, it was very heavily focused on the research and the producer or vendor side. Most of the speakers would be talking about those capabilities, their breakthroughs. And I saw very little activity on the consumer side of the ledger. And so I thought about this and I started talking to a large number of experts and people who would be on the consumer side, and they said the same white space exists from what they observed. So we started talking about how can we accelerate the adoption of quantum technologies, that's sensing, communication, computing, through a educational research service organization. So I founded Quantum Strategy Institute last year with that view. All the people who actually work at Quantum Strategy Institute, and it is a think tank, it's not a community, it's not a meetup. It's very much a think tank that's dedicated to the acceleration of the adoption of quantum. All the people that work there are volunteers. They have regular full-time employment, and they are willing to give their time to the acceleration of quantum. So let me give you a bit of a background here. I'm going to talk a little bit about the mission, the vision, the purpose, who's on the team, you know, the approach that we take virtually, what we're producing in terms of content, who our audiences are. And then I'd love to get into the sort of the meat of the conversation around the business adoption. How does that sound, Kevin?
Sounds great.
Okay. So the Quantum Strategy Institute, as it says here, an international network of cross-domain experts, you know, sharing their insights in terms of quantum technologies. They want to further the understanding of the practical applications across industries. You look at somebody like Rigetti, who has said to the world that they've set a revenue target of $600 million by 2026. So where are those revenues coming from? That's pure revenues, not investments. So that means they need to find consumers who are using their technology on a reasonably large scale. So what are those practical applications that they're going to be leveraging their quantum capabilities for? So, you know, that's very much what we're trying to drive. So how do we help bridge that white space between potential and practicality? One of the big challenges in the artificial intelligence world was 70% of the projects never made it to the actual shelf. And there are lots of reasons why that was true, but those who were most successful were able to provide small scale practical applications that succeeded and that they built upon and scaled. So rather than promising the world, you know, we need to have quantum companies that are actually producing something practical, even if it's small scale. So we're trying to smooth that intersection between scientific breakthroughs and business applications. And I'll give you an example. I recently wrote a post about two new elements. People spend years trying to understand a qubit. And recently, two new developments, qtrits and qquarts, have made the scene. But so how much do you really need to understand as a business person to make use of quantum computers? Do you need that depth of knowledge and understanding? And remember, 99% of all the activity that's going on in the quantum space is related to research and production. Only about 1% is on the consumer side. So we wanted to create this independent technology agnostic platform. We are not associated with any government. We're not affiliated with any individual corporation. And we want to help people understand how quantum can help them achieve business advantage. You think, I constantly get asked this question, Brian, what's the killer app for quantum? And I say, well, that's dependent upon your business, but obviously the one that really resonates with people is, I've got RSA type security in my business. You know, do I have to worry in 5 years that that's going to be overwhelmed by quantum technology? And so that's a very real fear. And so what are you doing as an individual company to start developing your capabilities internally and externally to deal with that eventuality? helping them build quantum readiness. And frankly, that could simply be a change management capability within the team. So your traditional sort of business activities that say, how do we deal with change? Where do we find our champions? Where do we create a culture around quantum? You know, how do we know which business problems to choose and make sure they're successful? And then, you know, taking those steps towards integrating quantum computing. We have somebody who's dedicated to that hybrid world of HPC and QC. And how do you create more seamless integration between the millions of dollars that you've already invested in classical computing with those really interesting applications for quantum? Quite often I get asked the question, are you saying, Brian, that I have to replace all of my classical computing capabilities? And that's not the case at all. And we want to make sure that people understand what hybrid means in the quantum world. So again, we're really sort of developing that landscape around the potential quantum technologies aligned with the reality of business demands. Again, if we're saying to CEOs and decision makers that you need to invest millions of dollars today in quantum capabilities, we're making a mistake. We spoke just this past week to a very large US insurance company who has yet to start down the path of quantum. So they want to know, what are our first initial steps, rather than saying we want to build out a whole team internally. So we need to be aligned with those business demands. And of course, demystifying quantum technology. You know, Russ and I were talking about our trajectory in terms of learning what quantum is all about. So whether that's superposition, entanglement, quantum mechanics, quantum physics, or it's, you know, what algorithms are most successful, or which types of hardware have reached the, you know, the next level in terms of capability. So there's so many moving parts within the world of quantum computing that people who are going to be making the buying decision can easily be overwhelmed. So what are we trying to achieve? So the successful adoption of quantum technologies. We want to give the business community that understanding around practical applications. There is no better way to sell quantum computing than with stories of success. And so we want to be able to provide those companies with those success stories. I think about organizations like ID Quantique from Switzerland, who are making massive inroads in terms of QKD, quantum key distribution, and quantum communication. They already have success stories, you know, and then enhancing the commercialization of quantum. So how can we help vendors think about their business development activities? When you look at our data from our Quantum Strategy Institute LinkedIn page, the #1 audience for all the work we're doing are the business development people. It's not the engineers, it's not the researchers, it's those people who are trying to sell their wares. So they're looking to us for ways to help them sell their products. And then we have a number of strategic goals around building awareness for our own institute, developing and publishing our resources, which I'll talk about in a minute. You know, growing strategy awareness. One of the things that I do in my own practice is I help companies develop a quantum roadmap. And so you can imagine that, you know, companies on the small, medium, and large scale are very different places, and the willingness to invest in quantum varies. So even if those companies aren't investing $1 in quantum today, they need to be thinking about what steps they're going to take to get to that place to remain competitive. And so I help them with quantum roadmaps. And Kevin, you're welcome to jump in if you have questions at any time.
This is all good. You mentioned the word revenue. I don't think we've really touched on that, the Rigetti. Just, yeah, keep going, because if you're able to help other companies develop their quantum roadmap, that means that you know what you're doing. And we need to know that information too, or just, you know, to glean from it, basically.
Well, you know, a couple of things there. Next week on January the 27th, I'm doing a quantum showcase with 3 of the companies that I actually developed roadmaps for. And so we'll do some more posts about that event coming up. It's a virtual free event. But the point there was we took companies who were very deep in artificial intelligence and machine learning capabilities and gave them the opportunity assessment, the questions, the ways to set priorities around how they can move into the quantum space, and in fact, leap ahead of their competition. And then the other point about revenue, you think about IonQ, for example, who recently published their first public financials as a public company. And not surprisingly, large cash availability, well over $500 million in cash available. But during that quarter, only about $500,000 in revenue. So we know that IonQ will, continue to move up its scale. They've just done a deal with Hyundai for EV batteries. So, we know that companies like that, their revenues will start to grow. But today, beginning of 2022, those revenues are low. And so, it's people like Russ's investment community who are saying, we believe this technology is going to be successful, but we need to see the revenues sooner than later.
Yeah, this is all good, Brian.
Okay. So I'll give you just take a look at some of the people on the QSI team. Danica Hannon is with Cambridge Quantum Computing, and she is now, which of course now is Quantinuum. Steve Haddon is the Chief Business Development Officer for Quantinuum. Matt Versace is the Senior Director of Artificial Intelligence for United Health Group, which is a Fortune 5 company. Esperanza is our Head of Change Management, and she works for Santander Bank in Madrid. Joe Galboni is the Head of Risk. He's a former Associate Professor in Lenahan University and now works for Q Risk Advisory in Paris. Ian Mason is our Head of Cloud. He's another Canadian, and he does a lot of AI cloud and quantum consulting. Amrita Manzari is based in India. She works extensively with quantum machine learning, quantum engineering, artificial intelligence, and she's starting to do courses on that. Anahita Jardashi, if anybody who's attended Quantum London would recognize this name. She's our Head of Industry Verticals. She works at Key Insurance, and she produced one of the most phenomenal papers about quantum and the insurance industry when she was attached to Lloyd's. So please look up Anahita and that paper, fantastic document. And then Mihaela Bercia, originally from Romania, now works in London, is our Head of Marketing. We're continuing to add more people. We've just added somebody from Business Finland to head up our government and consortium activities. And then we've added somebody from Quantum Machines in Israel to head up our high performance computing and quantum computing capabilities. So you can see that we've got a very diverse team who are experts in their field, and they're all very engaged in trying to help companies get through those quantum barriers. For the most part, the Quantum Strategy Institute is taking a virtual approach. We have virtual meetings, we attend virtual conferences. On occasion, some of our people will attend in-person conferences. I've hosted panels as well as some of the rest of our team. But you can go to YouTube and see a fair number of our videos that already exist. One of our key components, sorry, go ahead.
Hey, Brian, I'm Ryan Constantine. Just had a quick question before you move too far off. With your team, you have quite a large team. For at least for me, and I'm sure other people in here who are trying to develop businesses within quantum. I mean, like, is your team an average size for like just I guess like more of a consulting group, or like how do you get to a team that size, or how many people did you really kind of look for?
So that's a great thing, and I really, I don't know that there's a whole lot of benchmarks. Because Ryan, our model is such that all the people who are part of the team are volunteers. And so each one of those people that I've identified all have, a day job. And so the reason why these people have been attracted to QSI is a couple of fold. Number one is they are immediately exposed to a global network of people. And much greater than just the 11 people that are on our management team. Our board of directors is made up of people from Google, from McKinsey, from 1QBit, from Cold Quanta, those kind of examples. And so the network they immediately get is very extensive, but also the amount of access to expertise that they can use in their own businesses is readily available to them. So those were the sort of the key driving factors as to why they wanted to be part of this think tank. And as I mentioned off the top, we're not a community. We don't take memberships, that kind of thing. It's very specifically a think tank. So I'm not sure if I had a lot of benchmarks to compare it to, but that's kind of how we built, Ryan.
Got it. Awesome. Thank you so much.
Yeah, you're welcome. So very much we are focused on original content. So we produce articles on a monthly basis around topics that are relevant to the adoption of quantum. So for example, one of the first articles that I did was Quantum Evolution Approach with Caution. If we as an institute are out talking about quantum and we're hyping it up because we think that it's important for these businesses to gain revenue, we're not going to serve anybody's purpose. We have to provide a message that is balanced, that talks about the true sort of state of the industry, how people need to think about their quantum buying decisions. So we know that people are going to call us on this if we are, part of the group that's sort of simply overhyping this new immature nascent technology. So, we want to make sure that people understand that it may be that state today, but it is advancing very, very quickly. We also talked about educating the quantum workforce. This is a very specific technology that requires a very intensive approach. You can't just find PhDs in quantum engineers like our friend Salvador here just off the street. It takes years of development to get people to that level. So what does that mean in terms of educating your workforce, whether it be those individuals or the people doing the business development or the people doing marketing? How do they understand and spin the story for your company? We've done some articles around security and what is quantum development, what's truly happening in quantum security? What about NIST and, the quantum lattice versus, quantum key distribution? Where should I be spending my money and where should we be thinking about that? What are the developments that are happening? So, no one individual is going to make all those decisions and be able to answer all those questions. But what we're trying to do is point them into a place where they can find those questions and find the things that they need to discover. And of course, we do a lot of podcasts like Kevin's. Well, you know what? I should take that back, Kevin. We do a lot of podcasts. I think yours is somewhat unique.
Thank you. I don't know what that means, but it's fun and interactive. I think that's what you're getting to.
Exactly. I watched your last one with Kenna, and it was very interactive and very enjoyable. And so we attend conferences like Q2B and IQT and Quantum Tech. So we're very much part of that group. And one of the benefits of bringing somebody in from QSI is that there is no bias, there is no, incentive for us to appear in one way or another. So it's an exciting time for QSI to be part of the quantum ecosystem. So if you think about our target audiences, they're varied, whether it's industry, academia, media and enthusiasts, or the business community. I'll give you a couple of examples. Just last week, I met with the University of Calgary and the Quantum Algorithms Institute. They're busily working on some new course material for quantum at a master's level. We're working with the University of Colorado, for example. There's a real strong ecosystem in Colorado. And, you know, they're busily creating some new course material. And a couple of weeks ago, I did a post just on quantum education, had over 25,000 views. Clearly, people are interested in where they can find out more about quantum, not only from, you know, a buying perspective, but from a career perspective. So certainly we're very much engaged with the media. The Quantum Insider has done a number of articles on the Quantum Strategy Institute. Lots of activity there. I say one of our large group of followers is researchers, engineers, and software developers, because they have access to a lot of the technical research, white papers, and so on. But ours is a very different tangent for them to be able to sell their quantum ideas inside their company. So, you know, from a bottom-up perspective, if they've got some really great ideas and they want to be able to sell them into the organization, how do they find champions? How do they find those groups that they can work with, rather than saying, quantum, we don't know anything about that. Let's just put that to the side. So, you know, all these groups are sort of part of our target audience. Now, Kevin, I'm going to stop there because I'd love to spend some time talking about actual use cases. I just wonder if anybody has any questions about the Institute itself.
So first off, Brian, thank you. That was very good. My takeaway with this is QSI is highly organized, and a lot of us can learn a lot from that, as opposed to doing things kind of randomly. So Ryan had mentioned the big team that you have. That's awesome. And interesting that they're volunteers, all of my advisors, business partner volunteers too. And then I was wondering if you could actually, you kept saying vendors, like not coming from a business background. Could you kind of define who you mean by vendors? You said software, hardware vendors.
Yeah, so if you're thinking about, you know, the combination of Honeywell and Cambridge, hardware, software, now it's Quantinuum, they're a perfect example. Rigetti is another great example. IBM, of course. So those are the people that we're sort of putting into the vendor space. Companies like IBM who also provide educational opportunities, so that service element that goes along with it. D-Wave, as Salvador mentioned off the top, does a great job with videos. In terms of driving understanding of what quantum is all about. So we put those people sort of in the vendor space. The consumers are the ones who are either buying time on the quantum computing capability, or they are actually leveraging quantum services. So maybe I'm a drug company like Merck or Glaxo, and you know, we're using IBM's quantum capabilities to develop new drugs. That's the consumer side that we're talking about.
Okay. Yeah, this definitely helps, because a lot of this, what you're talking about, is like, this is a lot closer to home than a lot of us, I guess, in this panel would think. So you had mentioned think tank. Could you give your definition of that?
Yep. So my objective is to have all of these experts to bring together their experience and knowledge and create new content that is made available publicly. And so those groups get together for internal symposiums. We have regular monthly meetings, and we are thinking about how the quantum industry is trending, what its needs are, you know, what some of the challenges are, and those people are taking those, you know, challenges and converting them into original content that is valuable for the marketplace.
Okay. And then you mentioned Calgary. I vaguely remember seeing City of Quantum. Does that ring a bell?
That's right. That's right. So,
can you explain that? Is that a physical place?
Well, it is. It's associated with the University of Calgary premises.
Okay.
The city of Calgary itself is looking to, much like other cities have done with other technologies in the past, is looking to garner investment, make University of Calgary and its domains a quantum-centric kind of environment. A lot of that similar work has been done at the University of Waterloo with the Institute of Quantum Computing in Canada. So, I suspect that there are going to be many more quantum cities around the world as more campuses grow.
Awesome. So does anybody have any good other, I guess, Canada-based, because you had mentioned Colorado. So Kenna, obviously, who said this was fun last week, she said that things are moving between, I think it's Honeywell out there, and there's a buzz. So I guess a lot of us are looking to catch that buzz.
Yeah, and stay close to Colorado, whether it's the university, whether it's Quantinuum their efforts, whether it's the military that's based in Colorado,
Cold Quanta.
Cold Quanta, of course. They're making some real inroads. So yeah, if you're interested, make sure you stay close to that environment.
So this came straight off your, it wasn't QSI, it was actually your advisor site. I just thought it was very interesting graphic. Is this your actual business card here, Brian?
Yes.
Awesome.
Yeah.
And then, so this is actually, could you explain this, the Aquitaine here?
Yeah. Do you want me to unshare the?
Oh yeah, probably stop share. Let's see.
Yeah.
Okay, let's try this. And if anybody has questions, go ahead. Especially like Canada, I want Canada Quantum, because it comes up a lot. And then, so you guys seeing this now?
Yep.
Okay. So this is straight from your LinkedIn, Brian.
Yep.
200 plus endorsements. I roughly counted them. It might be 250 or 300.
Did
So
you really?
Yeah,
I've
yeah.
never done that.
Yeah, so 200 plus. So this shows, I guess, dedication to the AI and quantum. Obviously, with TD, you probably would have had your LinkedIn at that point. And then these are the business cards here that we were talking about. And then this is where we're at. Am I saying that correctly? Aquitaine?
That's right. So, Aquatainative Innovation Advisors is that company. As I mentioned, I do AI and quantum roadmaps for companies. It's also the publisher of all of my books. But before Quantum Strategy Institute, this was my main sort of domain. Pre-COVID, most of my work was in doing writing, but also in large-scale presentations. Frankly, that's an area that I really miss because I really enjoy that sort of adrenaline of being in front of large groups.
Awesome. So Alex, Khan, Aaron, and Sean, and VJ, if you have any questions for Brian right now. And then here we go, MIT. What good things do you have to say about MIT, Brian?
Well, as I was telling Kevin off the top, I finished my banking career about 5 years ago, and I had the good fortune to retire at that time. And so most of my work had been within the combination of business and IT projects, and I was always the business lead. And so I thought that'd be a great area to go into. And of course, at that time, 5 years ago, AI was just starting to trend. MIT was really the only one on the block that had an AI strategy offering. So I completed their degree program or their certificate program with about 500 other people around the world. It was phenomenal. The interaction that you were able to have with people from Dubai and from Russia, from India, was just fantastic through this sort of virtual space. And of course, as soon as I completed that, the phone started to ring.
Awesome.
I have a question, if you don't mind.
Yeah.
Do you mind talking on how is machine learning and AI, or specifically probably machine learning, being incorporated with quantum computing?
Yeah, and so I'm going to talk about it in sort of a very high level way, Ryan, in the sense that um, for I look at AI and machine learning being essentially the software that's running on top of the quantum infrastructure. So if you think about the full stack, and by the way, Doug Fink from the Quantum Computing Report has a wonderful graphic as it relates to the full stack. And so AI and machine learning capabilities, which of course are somewhat easily transportable into quantum machine learning, um, will allow you to leverage that software capability for some very, very complex tasks. And so, the world of AI and machine learning on classical conventional computers has done absolute wonders. But if you think about how it's going to, transition into quantum machine learning, it's just at the very beginning. But some of the people will tell you the biggest challenge is that very first part, which is how do you think about the translation from traditional machine learning into quantum machine learning? But I guess overall, what I would say is it's something that sits on top of the quantum infrastructure.
So is that more of a sense that you have the whole quantum infrastructure? Is this machine learning or / AI? Is that kind of keeping track of everything that's going on and holding it together and allocating resources in certain areas, or is it actually performing functions, I guess, as if it would in classical computing?
Well, it's similar to performing functions in classical computing, where you're actually, one of the benefits of artificial intelligence and machine learning was that question of repetition and being able to analyze and do something over and over and over again, millions and millions of times.
Yeah.
But of course, with quantum machine learning, you're taking something that has many more factors, exponential number of additional factors that you can now potentially assess, analyze, and come out with results. And not only a single result, but parallel results. So it's the old sort of question around doing the maze. You start a robot at the very beginning of the maze, and through conventional computing, you can only take one path at a time. Whereas with a quantum computer, you could take every path at the same time. And so, leveraging that from an AI and machine learning perspective, it really expands your universe of opportunities.
Awesome. Okay. So I guess it kind of flips the traveling salesman on its head if you can take every path at the same time.
Exactly right. You think about, we'll talk about that in the use cases of traveling salesman or salesperson and logistics.
Thank you.
So then TD Bank, Director,
Brian?
VP. Any
I'm
other
sorry,
questions?
Kevin. Sorry, Kevin, this is Vijay. So, Brian, being a service sector, guys, it is a bit difficult to convince them why quantum now.
Yeah.
So why can't they take it up when their hardwares are mature enough? So how to convince them? And second, what do you think about quantum inspired? Is this the answer to that why quantum now?
Well, so I think quantum inspired is somewhere sort of there in the middle. I think the question that I am always talking, and Vijay, I love this question. Whenever I have conversations with businesses, I rarely ever start with quantum and classical. I always start with a business problem that they're trying to solve. And, that business problem may say, I can solve it using conventional computing today, and that is fantastic. So, what if you could have a X level improvement in the analysis that you're doing? In the retail world, logistics is going to be so crucially important for whether it's food delivery or any other kind of distribution. And those retailers are going to need to understand how they can improve their distribution network. For marketing, for personalized marketing has come a long way in terms of AI and machine learning. But how do you get down to a consumer of one? And the only way you can really do that is by having something like a quantum marketing capability. Even if that's not available today, those companies should be starting to think about which part of their teams, which team members they need to bring on board, which new vendor relationships they might want to start thinking about, because that takes time. And if they're not doing it as quickly as their competitors, they will be falling behind very, very quickly. And so, that doesn't generate revenue for companies today, but there will be a significant change from 2022 to 2023. And that's not really a long period of time. So they need to have the conversations now. I hope that helps.
Thanks, Brian. It helps. Yeah, absolutely.
Okay, Kevin?
Yeah, so TD Bank, it says you were a director, associate VP, senior manager. You spent over a decade there. How did the banking industry influence your success in quantum today?
So it was a direct contributor, and not because we were doing quantum at the time, but because over a 20 plus year career, we were increasingly involved in technology projects. But I would tell you that I did this analysis in 2015. I looked at all of the major banks' annual general reports. Not one of them mentioned the word innovation. And the reason why was because innovation was considered a bad thing, because banks were traditionally followers, not necessarily fast followers, but followers, but also they considered innovation means risk. And they didn't want to take any additional risk as it related to challenges for your brand, for your customers, etc. That changed so quickly in 2016 when fintechs started taking their lunch. When these small companies using artificial intelligence capabilities started to take the payment space. They started to take the credit underwriting space. And so innovation all of a sudden became very important. Now, at the time, I was leading the financial crimes and fraud management group within a section in New Jersey and one in Toronto and a subset in India. And we needed to be able to get more data into our assessments. So we started to use machine learning. And so that for me was my introduction and the starting point for getting into the next step around AI and then quantum.
That's awesome. Yeah, I really appreciate that. CERN.
So, I do live in Toronto. CERN is not in Toronto. It's based in, Switzerland and Europe. The CERN course, I had heard so many good things about, and this was a very sort of deep, algorithm, logistics, logic level course. And for me, it was a great opportunity to try to understand it better. But it occurred at 4:30 every morning on a Friday. So it was very challenging to get up at 4:30 in the morning for a good 2 hours. But it was riveting. It was absolutely riveting from Professor Elias. And so, for, I think it was 6 to 8 weeks, I would wake up every morning and it was phenomenal. Russ and I were talking about where we learned it. I learned as much from this one course as anything I've ever learned. And they called it a 101 course. So, I'm sure there are much more advanced ones.
So you spent some time at McMaster University here. Anything for McMaster?
Well, so what McMaster was leading the charge on was actually, people from a continuing education perspective wanted to understand what artificial intelligence was. Just tell me what it is. What can it do for me?
Mm-hmm.
And that's where we started our connection.
Okay, so this picks up where we left off last week. Actually, Kenna had mentioned this article. Are you familiar with this, Brian?
Yes, absolutely.
Yeah. Any other members, feel free to ask Brian questions or comment. This is awesome. Like it's a very good sign for the industry, I would say. Somebody's dog commenting.
Yeah.
Oh yeah, Russ waves his hand. So this is,
can I stay on that one for a second?
yeah, sure.
So as I said, 6 of our 11 managers on our management team are women, and you know, their perspectives are just as important, equally innovative. You know, they bring so much experience. And as I said before, you know, from the artificial intelligence world, it was 85% men who were involved in the artificial intelligence domain. And I wanted to make sure that we weren't shortchanging our institute. And so not only do we have geographic dispersion, but we also have gender dispersion as well.
Yeah, it's good to be diverse. So this came out. Are you familiar with this, Brian? Anybody else want to talk about?
Only to the extent that, you know, what I've read here.
So this is good for Google, right? Spin out.
Yeah, well, all I can say is that, you know, Google's been working on, you know, what they called Sandbox for a number of years internally, and based on their recent communique, it looks like they're looking to spin it off. More than that, I'm afraid I don't know.
Okay. And then Aaron and Sean, would you like to ask Brian any question, anything that he's talked about? Alex, feel free to at any point. I just have to, you know, you can unmute. Let's see. So this one,
I have a question.
Yeah, go ahead, Ryan.
About Google. You may have answered that right at your last bit about Sandbox, but do you know anything about Sandbox?
No more than what I've read publicly, Ryan. Sorry.
Okay, that's okay. Thanks.
I would just say there's a lot of movement going on. I wrote a report last year. I called it the year, 2021 year of quantum computing partnerships. I'd say it's continuing this year, but I'd say, I don't know. I don't want to speculate too much as far as applications, that kind of stuff. This site has really good graphics. If you ever need anything, here's the link. If you need it afterwards, ask me. So this one has conferences. So it's all the conferences up and down. I think.
So can we stop there?
Yeah, sure.
So if anybody has ever thought about understanding the quantum ecosystem in one site, the Quantum Computing Report is that site. So whether it's people who are looking for jobs, looking at conferences, looking at the most recent, like Terra Quantum raised $60 million equivalents, and the major players, the new technology breakthroughs, the Quantum Computing Report has all of that.
Yeah, it's very well laid out too. So you were talking about this, Brian, like don't throw away your old classical hardware. How do quantum accelerators work? Well,
so this is where it's so, like, we think about high performance computing, and people have been talking about that and the definitions of it. One of our team, Quantum Machines, is very involved in, HPC data centers. And there are whole groups that meet on a regular basis talking about HPC data centers. So where your quantum capability needs to focus on individual problems, the question is, how do you integrate a quantum computing capability and accelerator in a seamless way so that you're not completely stopping and starting your analysis or your assessments in ways that, you as a data center, for example, have to, unload or to adapt your data into different formats? How do you do these things in such a way that you can leverage and transition your data analysis onto a quantum capability, not only for comparison purposes, but for operational purposes?
Yeah, say for instance, we have the San Diego Supercomputer Center, and you read that one report, it's like 76% of HPCs or supercomputer centers are expected to have some form of quantum.
Yeah, and again, the whole point here is that it's not meant to replace those high-performing classical computers or supercomputers. You know, there is at least in 2022, a place for both.
And it's relatively easy to have some form of quantum in all these data centers.
Well, so, you know, this is an interesting point because, you know, today's quantum infrastructure is based on clouds. So you've got your major manufacturers who have all of the hardware and you're getting cloud access to that. Data centers are that edge kind of environment where you can actually have the hardware look on your location. Cleveland Clinic is an example of where they've actually implemented a full-scale quantum computer on their premises. But that's rare. And so, you know, how data centers deal with the speed of access between an IBM or a D-Wave and their data centers becomes the critical element in terms of how are you making your investment decisions about whether you have a quantum computer on premises or not.
Gotcha. So would anybody like to read these 1 through 5?
Yeah, Brian, I have one question, Vijay, again. Sorry,
yeah,
Kevin.
go ahead.
Yeah, thanks. Brian, what do you think about regulations and compliance? As you mentioned, quantum systems are available over a cloud. Whoever accessing their data may be stored or have access to those cloud providers. And also there are multiple hardware providers and vendors available. So what is your take on compliance and regulatory privacy concerns?
Well, so, you know, you raise a great point because on two frames, you know, one is, what are some of the, you know, the players doing about collecting data today? And then secondarily, you know, what are some of the groups doing around regulation? And I would suggest to you that regulation is very nascent. You know, groups that are starting to talk about it, whether it's at NIST or it's in the European environment, there are very few structured regulations that are occurring. Some of the countries are starting to look at whether they sell their products outside of their region, whether that's the US or the EU, and some of the challenges that go along with that. You talk about, you know, there are dedicated quantum internet or quantum communication environments where data is being transferred between, you know, Beijing and Shanghai or areas of Illinois. You know, those things are not operating on a regulated basis. So the technology is absolutely outstripping the regulatory environment, but that will, you know, we would expect that's going to catch up. But because of the pace at which quantum is moving, that's going to be a real challenge.
So then, Christian, if you had any questions, and then if somebody wants to read these, the 5 trends for quantum science in 2022, Forbes had a report. Are you familiar with this? It's like how everything's going to go from R&D to IT. You know, they're going to have all this on site. They're going to be like this massive, you know, hiring spree, that kind of stuff. Well, this is an analogous one here too. So let's see here. This one is also interesting. You know, quantum-based encryption is closer than you think. Are you familiar with this, Brian? Quantum compute what's that mean as a service?
I've seen this. I've seen this this report, and what I would suggest to you around number 1 is that's absolutely true. If you think about the example that I gave you around quantum key distribution being used on a communication network over 4,000 kilometers between, you know, Beijing and Shanghai, you know, that's a massive improvement in terms of their encryption capability. The Samsung Galaxy phone that was introduced this past year now has a quantum random number generator chip in it.
Wow.
So the security capability for a consumer phone has gone up substantially. So there are things that are in market. Sure, there's a long way to go, but some fascinating things that are already going on today.
Yeah. Quantum's already here. I think a lot of people have that thing like you're just going to have a quantum computer in 5 or 10 years. You know, like the NSF prediction, 2023 practical. Google's, I think, 2028, 2029 practical. Quantinuum 2025 powerful. But yeah, quantum's already here. So what does this mean, Brian or anybody else? Quantum computing as a service.
It's the cloud access.
Oh, cloud.
You can go sign up now, and there's 8 different companies that have their systems online that you can. Some of them you can for free. You just wait in a queue. You can run an algorithm and wait in a queue, and others you can buy sometime. But you can do quantum computing today, and it's offered as a service over the cloud. That's what the QCAAS.
Okay.
Yeah, and you're buying,
service.
Russ is right, and you're buying, like a second of time on their computers, because that's all the analysis really takes. And then of course, additional services, whether it's, vendors creating algorithms or, running services on your behalf. They may not be the hardware manufacturer, but they may have access to the service.
Yeah, and you were talking about networking in the 400 kilometers, fiber optics, quantum internet. So what would a quantum internet be?
So you're going to hear about that in droves. So you think about today's traditional internet. It took years from 1995, let's call it, up to today in terms of its overall development. That time frame won't happen for the quantum internet. As soon as there is any sort of security threshold that's broken from an RSA or RSA equivalent perspective, communication will need to move to a new level. So encrypted and or based on a quantum internet. So companies will be looking at this and going, saying, what does this mean to me? What do I have to do to prepare for, transitioning, if anything? The benefit here is that a quantum internet will run on existing fiber optics infrastructure.
So then number 4, critical infrastructure grids. Go ahead, Salvador.
Yeah, thank you very much. There's one more reason for working on what we call now quantum internet, which is having a full quantum ecosystem for specific applications. For instance, detecting small changes, micro changes in gravity is a big thing, say, for earthquake modeling, several other natural disaster phenomena. So the thing is that sensors that are produced by using quantum mechanics, that is quantum sensors, play a key role, or could play a key role, in having enhanced sensing capabilities. But the thing is that in order to send the information that's being produced by a quantum sensor to a quantum computer or a classical computer, but most likely it's going to be a quantum computer, then we need to have a quantum channel. Otherwise, the translation of quantum into classical will make us lose a lot of very important information. So having that capability of communication between quantum systems, sensors, and computers is going to be crucial for several scientific and engineering applications.
And Salvador is absolutely bang on, because out of the 3 major categories of quantum computing, sensing, and communication, sensing has actually has the lead in terms of technology development. So that'll become even more critical.
Yep.
So then it says critical infrastructure grids will be early adopters of quantum security. Can anybody wrap their heads around that?
Well, let me give you one example. There are people who believe today that certain players are starting to collect conventional data for which they will use quantum computers to break the encryption. So, you think about various governments, large corporations, they're all looking for ways, they're all already started looking for ways to integrate this quantum protection, if you will.
So this one in Vienna, is this like another AWS? I think it was late November, they switched to hybrid jobs for AWS break it. Is this an analogous effort right here?
Well, it's interesting because what it does is it takes your computing completely off site. So theoretically, you run both your traditional, your conventional and quantum computing in a somewhat, sort of seamless fashion, with all of the data being run depending upon which type of computer you want to run it on.
Right. So Christopher and Brian has appeared as special speakers. I launched this website for Chemical Q Device, Quantum for Businesses.
By the way, what is Chemical Q Device?
Chemical Q Device is a medical device with quantum computing technologies. It's patent pending. And I've been working on it very, very much, just like how I take notes here. It's a 67-page patent pending. And then I've further developed it with other intellectual property. And then most recently, it's obviously been networking. This right here is an initiative to get in touch with the medtech, biotech, clean tech industries in San Diego, to invite them to events, offer consultants. I'll probably have more consultants too. Yeah, so basically this is one of the initiatives the Chemical Q Devices has performed right here. And it's a cool site. There's like, I listed like, I don't know, 20 or 30 different CAGRs. So major improvements in quantum fidelity. When I see these words like revolutionary, major, Oak Ridge National Laboratory, it probably means something. I guess
So,
most of us, Salvador, what does this mean?
Well, this is basically a quantum circuit.
Okay.
Yeah, a quantum circuit for, well, the QAOA is a particular way to develop quantum algorithms that takes, pretty much full advantage of the actual quantum hardware that we have now. The thing is that the quantum computers that we have now are not error corrected. They have a number of different potential enhancements in order to become fully robust and scalable quantum computers. But the thing here is that, I mean, you see the scenario is pretty much like the one we had with mainframes back in the 60s of the last century. So we need to find ways to use quantum computers so that the virtuous circle of investment, the applications, blah, 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 makes them grow more robust and stronger and scalable. So this is an example of a circuit for an algorithm that we can actually run in a hybrid fashion, meaning parsing on a quantum computer and parsing on a classical digital computer.
Okay.
So Kevin, I want to see on the next session that you're going to be able to explain what a quantum gate is. Okay. But before,
like you said, you have experts. Okay.
before we move on to the next one, the question
Speaking of, I'm going to defer to Brian. Well, Brian said he's not feeling too well today. But Brian is the quantum algorithm advisor for the company, and he could answer that for you.
So can I go back to the fidelity question? So this one is key because, if people only think of quantum computing as doing analysis faster, that's incorrect, because, fidelity and errors and noise are all part of the quantum ecosystem. The stability of a qubit, the ability to, reduce your errors, reduce noise. If you ever looked at a chandelier type refrigerator quantum computer, you start at the top, excuse me, and it gets consistently colder, but it also reduces magnetic resonance, any movement, all that, so it has to be very, very carefully articulated. Excuse me. So errors can creep into this whole process. And so this question of a universal fault tolerant computer that actually has no errors, years away. So, you as somebody who's making this investment decision must understand that this is not perfection.
Any other comments? So this is like Atom Computing Company, right, Brian? Or anybody else? Neutral atoms, first fully programmable. I think the 256 qubit that came a day after the 127 Eagle is also neutral atom. Or no, that was partial. There's so many different technologies.
So Kevin, I clearly see that you do your homework. My only question is, I've probably got about 15 minutes left. Do you want to talk a little bit about the use cases?
Sure.
Okay, so let me, do you mind if I share my screen again?
Yeah, go ahead. Let's see. It should. I probably have to stop mine here. So we'll take a breather right here.
Okay, so we good? We can see my screen?
Yes.
Fantastic. So, this is as core to the whole quantum ecosystem as any piece of technology, is a question of what it's going to be used for. So we think about companies like JP Morgan Chase or Citibank. They're, excuse me, already working with companies like Multiverse to really understand the portfolio optimization opportunities in quantum. And so those applications are already heavily being invested and being compared to traditional conventional computing. So not only do nanoseconds are nanoseconds important, but also optionality. So using quantum computers for portfolio optimization. Also, I'm working with a couple of companies. One is using it for anti-money laundering, and another is using it for estate planning. So, the uses cases in the financial sector are just going to continue to grow. In terms of logistics, Ross had mentioned the traveling salesperson problem. I don't know, are you familiar with that, Kevin?
It keeps being mentioned, but if you could explain it to me and other people too.
So let's say you have a salesperson who's responsible to go to X number of cities in one day. What's the optimal route for that person to go to all of those cities? Well, what if you add an additional city? What if you add 3 more cities? Well, every time you add an additional city, it becomes much more complex. So eventually, a traditional computer cannot any longer answer that question in terms of what's the optimal route for that person, that salesperson, to take. Excuse me. So add in weather, traffic patterns, availability, all sorts of complications, and it becomes very, very complex. There are some situations where transportation companies are still using spreadsheets or intuition. And so, the question of the optimal route for all of their fleet of trucks becomes very, very complex.
Mm-hmm.
This is where quantum computers, whether it's for Lisbon's traffic control or UPS's truck delivery system, to optimize the capability of where their trucks need to be when. D-Wave was working with the Australian military to identify where their supply trucks need to be on the field in battle in an optimal situation. So there are all of these, sort of use cases are already sort of in play.
Brian, can you touch about allocation problem also? That is assignment. So this is about route optimization. So how about workforce allocation? So it's a combination of assignment cum optimization problem.
That's exactly right. So we're combining optimization, yes, from the financial side into a logistics optimization, but you're talking about people optimization. So what sort of factors would go into a workforce criteria?
Yeah, considering different skill sets and different time required to solve the problem. Once he completed this problem, what is the assignment for the next problem? And depends on that, you have to work on that route optimization. So what is the nearest job next to him? And what is the effective way to allocate, especially this kind of where on-field fault attending kind of those problems, it comes into handy.
Well, exactly. And for example, if you have people who are absent because of illness, how do you then reconfigure your workforce? There are all sorts of possibilities. The question is it sufficiently complex for a quantum computer?
Yeah, one quick thought on this. So the same allocation problem, do you think the current pandemic situation, the same thing can be applied in a healthcare sector? So where do you put the staff nurses or doctors in shifts and allocating them, shuffling them on the need basis? So does it comes handy, and is it be a quantum heart problem?
So it can be, when you think about the extended part of that. So how do you, let's say you take rapid tests as an example. If you're not going to give it to everybody, how do you distinguish who those people are, where they're located, what's the best delivery system to get there? You start getting into those hard problems. So I absolutely agree that there are some significant optimization questions. I'm just going to move on, if that's okay, Vijay. from a
Yeah,
drug
please, please.
from a drug discovery perspective, at the very beginning of COVID, D-Wave offered its quantum computers for free to research companies so that they could work on the development of therapeutics, vaccines, etc. So fantastic offer that they made. And you think about companies that are looking for new therapeutics, new discoveries, and doing it in more real time. If you think about drugs, traditionally, it's about a 12-year time frame from initial concept to the actual shelf location. Once we started introducing artificial intelligence and machine learning, there were ways that actually could reduce that period of time where you could have much better confidence in the virtual testing that you were doing. So that might have reduced a 3-year time span in some cases of that 12 years. With quantum computing, you not only gain that speed, but you gain the opportunity to look at many more possibilities and possibilities you would never have considered in a traditional sort of concept to shelf environment. So we're going to see some major applications. Glaxo and Merck are already using quantum computing for those purposes. So it's an exciting time for drug discovery. And then finally, with security, we talked about a number through phones, through the quantum internet. One of the biggest interesting challenges, or sorry, not necessarily challenges, but evolutions will be the work that's being done at the National Institute of Science and Technology around standards for quantum cryptography and post-quantum cryptography. So, how are those standards going to relate to quantum key distribution, which is sort of something that's already available? And so companies are going to be watching that very closely, looking for people who have an understanding of the security world to be able to help them make those investment decisions, whether they be short-term or long-term. And so I've been invited to a number of security conferences to talk about this because not a lot of effort has gone into traditional security considerations for this kind of technology. I've just got a couple minutes left. Kevin, is there anything you want to cover?
Yeah, we could switch back here. So trying to find. So this is the whole, can you guys see this, silicon carbide? Is that showing up there?
Yep.
Yeah, so chromium defects in silicon carbide. As you may know, I'm a chemist by trade. And there's a lot of research, like I saw one in Wisconsin. So like you said, Brian, like we all see this like, macroscopically, and then seeing it on the research level, with your D waves and Rigettis and, whoever else's IonQs is now you're going to have academia look at it closer, So I just see everything. The more I research quantum, the more I'm like, okay, this is even better than what I thought it'd be. This kind of touches on other things that also, don't get rid of the old, keep the new, and then the events. How many events have you gone to, Brian?
In the last 3 years, probably 60.
Like in-persons or?
No, all of them, no, a few in person, but most of them in virtual.
Virtual, okay. So this is Quantum West. Do you guys know anything about Russ, or see who else would know? Maybe just Russ. Quantum West. So this is January 22nd. This is San Fran. So Ryan has left the panel. So Ryan lives in San Francisco, and he should know about this one. So then Developer Week, I'm sure there's somebody here that knows about IBM Developer Week. Salvador, you ever come across?
Yeah, I do. It's a very well-known thing for computer science students and graduates who are interested in
Yeah.
working on
So
ideas.
this is our San Diego one. So Brian, I hope you're available. February 18th, you'll get a free drink ticket. So this is Quantum for Businesses, like the website that I showed you. So I've been working hard with one of my business partners to get this going. It's in San Diego County, and we're looking forward to it. It's actually at a tiki. It's like a tiki base, like it's outside a, like a business office, and real fun atmosphere. So IQT, these are, have you done any of these online, Brian?
Yes, in fact, I hosted 2 panels in New York.
Wow. Okay. So these are huge. Definitely check out their website. They also have reports. They have news. Chris Bishop's podcast, Quantum Pod, something, his podcast. So these are definitely worth checking out. So this is February 21st at The Hague. So I'd be surprised if anybody here has been to The Hague. I still want to hear from some of the other people, Christian or Aaron and Sean. Like I said, with Aaron and Sean, they're the first ever 2 people on the same channel there. And then obviously, this is our special speaker. So this is January 20th, 2022. Special speaker, episode 14, Brian Lenahan, talking about all things quantum from the business perspective. Brian is the author of Quantumbased, a book everybody should check out. Lots of people have recommended. Any last questions for Brian?
Yeah, Kevin, thanks. This is Vijay again, sorry. So I know post-quantum crypto era is catching up. Currently, the quantum security is restricted with quantum random. So Brian, any thoughts on that? Only a key with the quantum random, how it can be far more secure or competitive with the pseudo random?
It's a fairly long response, but I guess what I would say is true randomness will be a very important part of this capability, and not everybody has achieved that sort of true randomness capability for security. I do want to just say quickly to Salvador, I've taken a copy of your links, Salvador, and I'd love to follow up with you on your course.
Thank you very much. Of course, the first one is already recorded and fully recorded, and I'm thinking of having a new version of it in the second half 2022. But the second link that I shared with you all is an ongoing course that we're having right now on an advanced method for quantum algorithms. So yeah, more than welcome, and thank you very much.
Fantastic. And you're based in Mexico?
I am indeed, yeah, in Mexico City.
Fantastic. Great. Sorry, Kevin.
So if you guys want to download the chat, now's the time to do it. I don't really have anything else. Russ, if you want to show us your dog.
Yeah, she's in the other room now.
Oh, okay.
She's very cute.
Yeah. So for those that weren't on, we heard the dog was part of the panel too. And any last remarks, Brian?
No, but thank you very much, Kevin, for inviting me. I really appreciate it, and I'm sure we'll keep in touch.
Yeah, you're welcome. Thanks
Brian.
again. Appreciate it, Brian.
Okay, thanks all.
Yep. Have a good night, everybody.
Thank you very much. Have a good night.